Just a suggestion. If you're looking at qualitative driving variables, now when I say qualitative, I can't put a number on a cultivar. A cultivar's got a name, okay? It's a discontinuous driver. A fungicide, soil type. I generally use analysis of variance to work out the effect it's having on the population. When I have quantitative variables like temperature, time, number of whatever, okay, and I'm looking at that effect on disease or plant growth or something like that, okay, I generally use regression. Now that's not written in stone, but it's written in fairly hard clay. Okay. So the point I want to make is that when you plan, you also need to know what are my driving variables. Are they qualitative or are they quantitative? Okay. And your analysis that you use will then depend on that. So if I'm looking at temperature effects on the growth of or the germination of Buccinia spores, okay, I'm going to use regression to look at the relationship. I'm not going to do an analysis for every temperature. I have seen that done in journals and things, and
yeah, what would you do if you have only 2 temperature regimes and then spore germination?
I'll tell you in 5 minutes, 2 minutes. Okay, right. Good question though. Okay. I just want to make the point on that. If you're going to look at relationships, and I use as a rule of thumb, okay, a minimum of 5 variables. Okay. I'd like more, I'd like to say a minimum of 10, but sometimes it's not practical. But if you've got less than 5, you're not going to see any kind of shape. And the other point I want to make is they need to be fairly diverse. It doesn't help you have 4 that are around 0 and you have 1 that is around 10. You're also not going to get the relationship. So, but I'll come back to that when I do regressions. So let's start with one of the most simple tests, and I've referred to the t-test in a number of times, and I refer to the t-value. Let's assume I have 2 cultivars, okay, or 2 temperatures, and I'm looking at spore germination. But I have 2 cultivars. There's MFC, which that's a cultivar that Saki likes very much, okay. And I have this cultivar. And I have the yields. Now I've taken 10 samples, and I've worked out the mean of those 10 samples from each of those cultivars. Now the question is, do they differ? Now remember I said I'm interested in that 95% of the population. I don't want them to overlap. I want to make sure that they are 2 distinct populations that don't overlap. So the question is, do the sample means differ significantly? And for that I use the t-test. Now the t-test is a very simple test. It's the difference between the means, so it's that mean minus that mean, divided by the standard error of the difference. And that's why I introduced standard error just now. Now it's quite a difficult, the standard error of the difference is quite complicated. I don't expect you to work that out unless you really have to with a calculator. But basically, the difference between these 2 means is 4.27. The standard error of the difference is that amount there, and the t-value that I calculated is 0.95. Now, I've got 10 samples there, and I've got 10 samples there. I have 9 degrees of freedom here, and I have 9 degrees of freedom there. So I lose a degree of freedom for that one, and I lose a degree of freedom for that one. And you'll see the degrees of freedom that I'm using is 18 and not 19, okay? So I'm losing a degree of freedom for each one of those. And the degrees of the t-value for 18 degrees of freedom is 2.10. that value there is smaller than 2.1. You know what I did is I changed this and I haven't, I'll fix it before we put it in your notes. Okay. For 18 degrees of freedom, it doesn't matter. It's still smaller than 2.101. So the two cultivars may be regarded as coming from the same population. In other words, there is no difference between that one and that one. Okay. It's a simple use of the t-value. Okay. So I've got the distribution, I've got the next distribution, and I've got the t-value. And if the t-value is not big enough, it means that I can't say with a 95% certainty they are different. Okay. Now, if I did the same thing and that t-value was bigger than whatever the correct t-value is. So in other words, if I did the calculation and that was 3.95, for example, I'd be able to say that the means differ. So the t-test is a very, very simple test to do if you want to compare two temperatures, as you asked, or two cultivars, or I have two fields, the one's been treated with something and the other one's been treated with something else, and I want to know if that treatment or those two treatments had an effect. And it's a very simple test. It's probably the most basic statistical test that we can do. Now, I did say that this looks a little bit complicated, and people get very worried when they see things like that. That is why we got Excel. Okay, so if you go to Excel, and no, that's application 2. Sorry, let me get to the correct one. These are all in your examples that I gave you. Okay. There I have the severity of disease in two fields. Okay. I have the 10 samples that are measured. And the thing is, use the T subroutine in Excel to compare the means of the two fields and draw a conclusion. Okay. In Excel, provided that you have uploaded it, you'll see that you've got a data analysis block. So if you go to data analysis, somewhere on that list, you will see there's a t-test. Now, it gives you some options, assuming equal variances, unequal variance, and so forth. When in doubt, use assuming equal variances. Most of them will give you a similar sort of. Okay, so it's going to ask you the two variable ranges. So you're going to say variable 1 is that one there. And variable 2 is that one there. So I've got my two variables identified. And I'm just going to tell it where I wanted to dump the data. And I'm going to say dump it there. And I say OK. And what this does for me, it provides all the information I want. So I have the mean of that one, and I have the mean of that one. Okay. I have the variance of each of those. I have the number of observations. It works out for me that pooled variance, that horrible formula. Okay. You can put in a value there. Let me just widen this column a bit. It can put in a value there where you can actually put in a hypothesized mean difference, but you can leave it blank. I have 18 degrees of freedom. Remember, I lost a degree of freedom there and there. And the t-statistic it works out is 0.08. Now, don't get hung up about whether it's positive or negative. That's not important. What is important is the size of that value. Now, If you remember that for 18 degrees of freedom, the T value was 2.1 or 2.01. Okay, call it 2. That value is a lot bigger than 2. So what does it tell me? Very simply, that the severities in those two fields differ from one another. Okay? With a 95% probability. And that's the value we generally use. You can go stricter if you want to, but let's stick to 95. And that would be your t-test. It's on your notes if you want to try it out, if you want to run it. Okay? And that then will give you the difference between two samples. Remember what the question was? Do these two cultivars, temperatures, whatever, differ from one another? Okay? The t-test is a good value or a good system to use to do that. Does that make sense? Okay, it's very simple, very simple. Okay. So where was I? Somewhere here. Okay, and there are examples in the notes here where it's been worked out as well.